Meet Nova, your personalized AI robot that you can build from scratch at home. After the AI revolution, the era of robotics is here. Big companies like Nvidia and OpenAI have already launched their robots just this year. The demand for robotics is about to skyrocket. So are you prepared? Do you have what it takes to be successful in the field of robotics? My name is Murtaza Hassan and I have studied Masters in Robotics from a university that ranks within the top 30 universities of the world. And trust me, the theoretical skills taught at universities are not enough to get you started. But don't worry, I have been working in the field of robotics for the past 10 years and I have designed a practical robotics course for absolute beginners, which will be a perfect gateway to enter into this field. So what exactly is in this course? You will learn the basics of hardware and software to build your first robot using readily available components. We have split this course into 3 tiers. The basic tier will get you started with the hardware design using cardboard and it will teach you the basics of motor movement and speech. In the advanced tier, we will take it a step further and make the robot smart. First, we will upgrade the design with 3D printed parts instead of cardboard. We will integrate a screen with animations which will give it a character and add emotions. Then we will learn advanced motor control along with custom gestures. We will also learn advanced memory management so that it can learn and develop over time by itself. The third tier is the pro version of this course. Here we will integrate a camera module giving the robot the ability to see, which will open up a massive door of possibilities. We will learn by creating projects including face tracking, face recognition, hand gesture control, object detection, what do you see, and more. We want everyone to get started with the field of robotics. Therefore, if you want to get a taste of this technology, you can go for the basic tier, which will be completely free. But if you are serious about the field of robotics and you want to advance in this field, then the paid tiers of Advanced and Pro are the right choice for you. And don't worry, you are in safe hands. This isn't our first course. We have created top-rated courses like Learn OpenCV, Drone Programming, and Computer Vision Web Development. Our courses rank number 1 on YouTube and Google for a reason. We don't waste your time. We pack in maximum knowledge in the shortest time possible. So if you have basic Python skills and a passion for robotics, you can complete this course in just 1 week. Join us today and get a head start in the exciting world of robotics and AI. Welcome to the basic version of Build Your First AI Robot course. In this course, you will learn how to create your very own personalized AI robot, Emma. Emma is designed to be simple yet impactful, built using affordable and readily available materials like cardboard, Arduino, and servo motors. This course is perfect for beginners who want to take their first steps into the world of robotics and AI in an exciting and approachable way. Your instructor for this course is Ms. Zainab, a highly skilled and experienced robotics engineer. She has a strong academic background and years of hands-on experience in designing and developing innovative robotic systems. So let's go ahead and get started.
Chapter 1, Introduction. What is robotics?
So, what is robotics? Or what exactly is a robot? Simply put, it's a machine that can mimic humans and perform tasks. Robotics blends 2 key areas: hardware and software. Hardware includes motors like servos, sensors such as cameras, and structural components as well, including its body and links, as well as the electronics that ties everything together and powers it up. The software is what brings this hardware to life. It involves programming and your AI integration as well. Now, robots are used all around the world and they have a lot of applications. Let's discuss some areas of robotics. We have humanoid robots like Sophia that can mimic human gestures, speech, and expressions. We will be building a humanoid robot within our course. Next up, we have aerial robots such as drones that can carry out package deliveries and aerial photographies. Then we have robotic arms that can carry out manufacturing and even surgeries. We also have our land-based robots such as autonomous cars, and then some other domains such as marine robotics and soft robotics. The field of robotics is expanding every day thanks to AI. So what makes these robots smart? That's where artificial intelligence or AI comes into play. AI allows your robots to think, learn, and adapt. But AI is not a single tool, it's a family of tools. Some domains of AI are machine learning, in which robots improve their performance based on data, such as robots competing against humans in chess, and so on. Then we have our neural networks that can help robots in recognizing patterns and making decisions, such as facial recognition and object detection in autonomous cars. Thirdly, we have natural language processing or NLPs that allow robots to understand and respond to human language, such as Siri and Alexa.
Chapter 2, Installations, Python installation.
Alright, let's install Python 3.10. I'll just type in Python 3.10 and click on the first link. Scroll down. Download the Windows 64-bit installer. Run it once installed. Add it to path. And click on Install Now. Okay, once it is installed, you can go to your command prompt. Just type in Python ---- version, and it will show you the version that you've installed.
PyCharm installation.
Alright, so we'll be installing the PyCharm IDE. An IDE is basically an integrated development environment. Here I am on the official page of the PyCharm download. I'll scroll down and we'll be using the community edition as this is free to use. Click on download and wait for it to download. Alright, so here we have our PyCharm community edition installed. Let's open it up. Yes. So the PyCharm Community Edition setup opens up. You just need to click on Next. Select the destination folder. It is selected by default. I would suggest not changing it. Just make sure you have the space. It's 1.7 GB. It's a little bit heavy, so just make sure you have the space. Okay, so let's create a desktop icon and make sure to add bin folder to the path. And click on Next. Install. Wait for it to install. Alright, once it is installed, just click on I want to manually reboot later and click on Finish. Now you can see your PyCharm is successfully installed and you can open it up from this icon over here.
PyCharm setup.
Alright, let's set up our PyCharm. Double click on PyCharm Community Edition. It's opening up. So this is how the interface looks like. Currently I have a project open. Let me just close it. Okay, I'll click on the icon over here and then go to File, New Project, and then I can create my project. Let me name my project as Emma the Talking Bot. Okay, I'll save it in my CV Zone folder. I do not want to create a Git. Okay, now this is important. You'll have to select the Python interpreter that you want to use. So if your computer has multiple Pythons installed, make sure you're selecting 3.10.0. And for this, make sure that you have already added it to the path. Create this window. Okay, now here it has created a virtual environment for you. This is our project name, project folder. This is the virtual environment. The libraries folder will have all the libraries and dependencies you have installed. Now moving on to the dependencies that we'll be downloading. All right, so now we'll be adding a file to our project. Just right click on your folder. Click on new, then go to Python file because we need a new Python file. I'll be naming it main. You don't need to write .py, it does that for you. All right, so it just created a Python file for us within our project. So let me try if the interpreter is working. Print hello. Okay, just make sure on the bottom right corner over here that you have selected the right interpreter. It shows 3.10 Emma Talking Robot for me. So it means that my interpreter is selected. Now you can either run your file by right clicking and selecting the run main over here, or you can simply just click on this button over here to run. And there you go, prints your command in this output terminal over here. As you can see, it also has these other options. So if you go to the terminal, this is an integrated terminal, and you can basically just install different libraries from here that we'll be using in the next part.
Packages installation.
All right, let's install our packages. So these are the main packages that we will be needing. It is all in the requirements.txt file. You can download it from the website. So PyAudio package, we'll be needing it for acquiring audio from the user. Speech recognition will help us convert speech into text. We'll be using Google Generative AI's Gemini API for generating a response. This will be the main AI model we'll be using. Then we'll be using OpenAI for generating a voice and Pygame for running the voice. So this is basically speech to text and then response generation and then text to speech. Okay, so click on your file over here, go to settings, the settings dialog box pops up, go down to project, Python interpreter, and here you can install all your packages. This is the interpreter or the project we are working on. You can select it if it doesn't show up, like the correct one doesn't show up. So let's click on the plus sign over here. Okay, so the first file I need is PyAudio. Just type it in, and here it shows whatever version, latest version is available. Click on install package. You can see it's installing. We will also need speech recognition over here. Let's install. So you can see all the dependencies installing over here. This blue loading line over here shows us there's a background download going on. Next up, we need OpenAI, install, and then Pygame. You can specify your version if you want, but I'll be going with the latest versions because the Python I'm using right now is very stable. It's 3.10, so most of these packages are fully supported. Let's install the package. I did not install the Google API package right now. I'll be installing it later using the command prompt. I'll be installing it later using our integrated terminal. Close it. So as you can see, it installed more than 4 libraries. It also installed all the dependencies that were with our packages. So here you can see it installed Pygame. This is the version it installed. This is the latest version. Once again, you can always select what version you want to go with. Okay, this is all that we'll be needing for now.
Arduino IDE installation and setup.
Alright, so for connecting our servo motors with our computer and then coding them, we will be using the Arduino Uno. And for that, we will need its IDE. So what you can do is just type in Arduino or go onto its website, which is arduino.cc, and download the IDE. Alright, so I'll head into softwares, just accept, right, software, and you can download the IDE from there, the installer. Okay, if you scroll down, you can see which IDE suits you. So I'm on Windows 11, so I'll download the installer from here. Just download. All right, and it starts downloading. Let me go back. Right, so we'll be using the IDE 2.3.3. This is a much interactive IDE, so we'll be using this. But if you want a much stable and a much comfortable version, then you can also head on and use the 1.8 versions over here. These will work just as fine. All right, so here I have the setup, so just agree to everything. All right, so for this IDE, it's important that you allow all the driver permissions so that it installs all the necessary drivers. If it doesn't, then you'll have to head on and search up CH340 drivers. These are for Arduino boards, so you can download them as well if your board is not connecting. Alright, so here my IDE is installed. Let me finish. Right, so here is the IDE. This is how it looks like. It shows your file name over here. Then it has this workspace where you can code. You can select your board from this menu over here. Right now my Arduino is connected on Arduino COM11. Sorry, right now my board is connected on COM11, so I'll just select that. And down over here, it shows which serial port is connected. All right, my Arduino board is connected. Now let me upload this file. And as you can see, the TX and RX LEDs, they blink for some time. This indicates that your sketch has been uploaded. So the code that we write over here is known as sketch, and over here in the output console it shows how much storage it took up and whether it has uploaded or not. So we will be using this IDE for coding our motors for our robot Emma.
Chapter 3, Hardware, Building the Robot.
For making your cardboard robot Emma, you can recycle any cardboard box you may have at home. Just make sure it isn't damaged and is clean. Here is a template we are using for the robot's head, torso, and arms. The body is big enough to fit 3 MG995 servo motors for both the arms and its head. The cardboard I'm using over here is single wall. You can either print the template on a regular piece of paper or a sticky one. Here I am tracing the body parts onto the cardboard. Use a cutter to cut the body parts and use a smaller pair of scissors for trimming out and giving it a cleaner look. As you can see, a single wall cardboard is easier to cut and gives good strength as well. Now for the front, this time I have printed the template on a sticky paper. I'll cut it out, paste it on my cardboard, and then trim it out in a similar manner. Make sure to clean its edges as well. Next up, for the 3D model, we will cut out the strips of cardboard according to dimensions given on the template. You can download the template from the website. We'll be cutting 2 body strips of 21 cm length and 6.5 cm width. Then a single strip for the head, which will be the length of an A4 and 4 cm wide. Similarly, 2 strips for the arms, 20 cm long and 2.5 cm wide. After cutting out long pieces, we'll be using a cutter to make slits along the length of the cardboard. These slits are less than 1 cm apart for the model and even closer for the arm strips. Here we have all our pieces cleanly cut out and ready to be assembled. Alright, moving on to the assembly. Let's assemble the torso first. Make sure to cut at its bottom for a straight base. Alright, let's heat up our glue guns. Be very careful with the glue gun as you don't want to be getting blisters. Start by assembling the right strip of the torso. Apply the glue gun on the inner side of the cardboard. Keep the slit side inside and hold down the cardboard for sticking it together. Make sure it's on the inner edge so your glue is not sticking out. Complete the rest of the torso similarly. Next, for the head, I'm using a single strip. As this piece is more circular, we'll apply glue on smaller areas and stick our pieces gradually, curving it. Make sure to press down for a stronger model. Finally, here are the arms. I've cut smaller and closely packed slits as this is more defined. Be very careful as the glue gun's tip is extremely hot. Similarly, glue the other arm piece together and attach its back sides. Here is our final model. I've left a gap on the bottom of my torso over here to attach it with the base. Alright, let's install our motors. For housing our joints, we'll need to cut holes. 2 on the sides and 1 on the top for our head. Make sure the holes are aligned. The holes need to be 1.3 centimeters wide. I'm using a drill machine to cut the holes and then a filer to make it circular. You can also use a solder iron as well, it works. Use glue gun to attach the motors. Apply glue on the face of the motor and press it against the inner cardboard side of your torso. Hold it for some time so that the motor is fixed. Make sure the wiring is not glued together and it hangs out so that you can integrate it later with your Arduino. Here is my skeleton all ready. Moving on to the aesthetics, we want our robot to look cute and friendly. For that, we'll be going for a white and blue theme. So we have two ways. You can either print out the template we've provided on a sticker paper and stick it on your robot, or you can simply use white pages and blue cardboard paper to make its body. So basically I used stickers and figured it didn't look that neat, so we went for the paper model. So what you can do is print the template, cut it out and stick it on the front sides of the robot. Also make sure to stick a piece of cardboard on the bottom to attach your robot with the base. Then use A4 papers to cut out white strips for the sides of the model, torso, arms and head. I'm using a blue cardboard for its shoulders and ears. You can make its ears by simply placing bottle caps to draw circles and then cut them out. Stick them together for volume and cover in blue and white paper. Finally, for attaching the arms and head with the servos, we use circular servo attachments. Use glue gun to stick on the bottom of the head and on the arm sides. Alright, let's assemble it all together. For the base, I'm using wooden planks. I'll cut 2 wooden pieces using a circular saw and then attach them together using glue gun. The robot's base will be elevated. I'll use black for the robot's base and white for the back of the base. Finally, attach Emma on top of her base and she is ready to go.
Wiring.
Alright, so here I have my hardware components that I would be needing for building my AI robot, and I'll be discussing the wiring and the components required. So first of all, we will be needing this Arduino Uno Rev 3 board over here. Alright, so this is the Arduino board that we would be programming. We would be connecting it with our laptop using this serial COM cable over here, and we will be using its pins for interfacing our servo motor. But instead of directly using a breadboard or connecting our servos, we would be using this sensor shield over here. So this sensor shield would allow me to connect as many as 12 servo motors over here. I'll only be needing 3, so I'll be using this for connecting my servo motors. So what you can do is just plug this onto your Arduino board over here. Just make sure that the pins align with the ones at the bottom, just like that. You can push it in. Alright, so now our Arduino board is ready to be interfaced with servo motors. Alright, so the servo motor that I would be using is this MG995 servo motor, which will allow me to rotate my head and my arms. I'll be using 3 of these, and over here let's discuss its pin out. So it has a power cable over here, the red one, and the brown one is its ground cable. The orange one would allow me to code an angle on it, so it's the PWM pin that I would be connecting to S over here, which is the signal. So if you look onto your board over here, you can see right over here I can connect my digital IO pins. IO stands for input and output. So I would be connecting my pins of my servos right into the pins over here. The power and S is the signal, so I'll be connecting it this way. So the orange one is facing down, and I'll just make sure to note which pin I connected on. Let me connect it to pin number 8. Just make sure you push it all the way in so it connects. Alright, and over here I also have a battery over here. You can connect an external power if you want, otherwise your motors should be working fine just with the PC connection. I mean, it should be powering through your PC. Alright, so here I have my servo connected to my Arduino board. Right now it's free and you can rotate it. It should rotate to an 180-degree angle. You can hear the gears turn. Alright, now let me power it up. Alright, and my servo motor goes to its rest or starting position, which means that it is working just fine. Now let's move on to its connections on our robot Emma. Alright, so here I have my Arduino board along with the shield placed on the base of my robot, and let me connect it. So I have my L servo or my left hand servo, which I'll be connecting to pin 8, and then I have my R servo, which I'll be connecting on pin 9, and then my head servo, which I'll be connecting on pin 10. Just make sure that you follow the G, V, and S labels that are labeled on the leftmost of your pins. G is ground, and make sure you connect the brown one on top, and then the red one, and then the orange one. It should be at the bottom. The S is the signal one. In the video, it's inverted, so make sure you follow it correctly and don't accidentally connect the wrong pins. Okay, I also connected the power over here. My red pin is in my VCC and my black pin is in my ground, but you don't need it. It's optional if you want it. Otherwise, you do not need an external power for your motors. Generally, your motors need 5 to 6.5 volts to operate, and your laptop should be enough to provide that voltage. Alright, so this is how my connections look like. Pins 8, 9, and 10. The orange ones are at the bottom. Alright, let me power it up. There you go, and my motors move to their rest positions.
Chapter 4 Motor Movement Overview.
Alright, so far we have discussed how we can create Emma from cardboard, and we have connected the servos in place as well. Next up, we will be discussing how we can control its servo movements and make its limbs move. We will be coding its arms as well as its head movement. And here is an overview of how we would be doing it. So after you have connected your servo motors with Emma through an Arduino shield and connected to your Arduino board, next up we will be coding our Arduino board and interfacing it with our MG95 motors. We will be using some specific libraries, including the CVZone library and a special servo library as well. This will help us in conveying angles for our servo motors, which can move through 0 to 180. And then once again, using the CVZone library, we will be creating a function within our Python code, which will help us in conveying these angles and movements through our Arduino to our motor, resultantly making Emma move. So let's discuss how we can do this.
Arduino setup.
Okay, so the first step in interfacing with our servo motors is coding our Arduino board. And for that, we will first be installing the required libraries, including the CVZone library and the servo library. So you can head on to the download section and download the CVZone library over here. I have already installed it. It's in a zip format. Now I will be downloading it within my Arduino IDE. For that, I will be heading on to Sketch and then include library. I already have a lot of libraries over here. Just head on to the add.zip library over here and give in the path to your CVZone zip file. Right, since mine is on my desktop, so I'll just click it and open it up. And since I already have a library installed, it asks me if I want to overwrite it. I'll just say no, but it won't ask you. You can just download it and it should be set up and ready to go. Okay, the other library that we will be installing is the servo library. So after trying out multiple libraries, the library that works best for me is this one. Let's head on to library manager and type in servo. So I already had typed in servo over here. And the first library that pops up for me is Michael Margulis's servo library. And I have already installed it. You can just press this install button over here and install it. If this doesn't work for you, you can also head on to its official page and download the zip file and add it just like we did for our CVZone library. This will help us in interfacing with our 3 servo motors. Alright, so once you have installed all the required libraries. Now we will be heading on to our code. So as I previously discussed, our Arduino IDE will kind of be our interface between our Python script and our motors. So we will be using the CVZone library for establishing communication and then writing the angle to our servo motors. So let's look into our code. So the first few lines are me including the libraries. Then I am using the servo library to declare my servo objects over here. So since I am using three different servo motors, one for my left, one for my right arm, and then one is the head servo, I am declaring three servo objects over here. Make sure you add the semicolon. Once I have declared my servo objects, then I will define what pins on my Arduino shield they are connected on. These can be different from you. We have already connected these when we were assembling Emma, so we will be going on with these. If the pins are not working for you, you can change these according to whatever configuration suits you. So we have our servo pins set up over here. We have declared the object as well. Moving down, now this is the part where I will be establishing communication with my Python code, these two lines over here. So I will be using CVZone's serial data class over here to create a serial data object which will help me in communicating with my Python code. If you press your control key and click on this class, you can head on to its declaration over here. And the function that we are using for it is the serial data function over here, the serial data class, sorry, the serial data constructor over here. And let me head back over here. If you can see, I have created my serial data communication object or variable over here, which is taking in these two parameters. So let's discuss these. If you head over into its declaration over here, you can see that it takes in two values. One is the number of values received, which is by default 1, and then we have the digits per value received. Since we have three different servo motors, so we will be receiving three different values of angles, hence this value would be 3. And then since the angles are between 0 to 180 for our MG95 motors, the digits we will be receiving per value is 3 as well. Hence, you will be declaring the input parameters as 3, 3 over here. And then for storing these values, you will be creating an array over here by the name values received, which also has 3 elements in it. So this is an empty array for now. So all the code above over here, we have initialized all required parameters and variables. Next up, let's move on to our setup and our loop. So let's discuss the setup first. For establishing communication from our Python code with our Arduino IDE, we will be using serial data.begin. So this will initialize serial data communication. Next up, we will be telling our Arduino where our servo objects are connected through the dot attach method over here. So we already declared the pins. Now we just need to tell it where the respective pins are connected by using the dot attach method. This is all about the setup loop over here. It just runs once. Next is our void loop, which runs indefinitely. So let's discuss what it would be doing. So first off, I have my serial data.get, which gets the values received array from our Python code. The format in which this will be getting our code, getting our values is this. So it would be getting an array of angles for left, right, and head servo, which we will give in from our Python through serial communication. And then the values that it gets, it stores it in values received. And then what it does is simply write these values to your servo objects over here. So 0 index is for the first value, which is our left servo. 1 index is for your second value, which is your right servo angle. And then the last value, or the index 2 over here, is for your last servo over here, which is our head servo. It just writes it and keeps on receiving your data from Python code and writing the angles to your servo motors. So you just need to upload this code once to your Arduino board, and the rest of the work you will be doing on your Python script. Alright, so let me plug in Emma on my USB port. Okay, so the servo motors move to their initial positions. So these are the 0 angles for Emma over here. For my right servo, my L servo, and then my head servo. So you can see on my Arduino IDE over here, move this over here. So it says that my Arduino board is connected on COM3. Just make sure you select it from here as well, and then just upload the code. So it will compile your sketch. It calls this whole script as sketch, and then it will upload it. Just need to do it once. Done uploading. All right, great. Now we can move on to our Python code.
Python script.
Alright, now that I have uploaded my sketch to my Arduino board, I can head over and code in my Python IDE over here. So head over to your PyCharm project and create different folders. Right now, I will be creating one folder by the name hardware within my project file, and I will be adding in my hardware codes within it. So for my servo interfacing, I have my servo's basic code over here, which I will be discussing now. All right, so this Python script will help me in communicating my servo angles through my Arduino board and then to my code. Right, so my Python code will help me in communicating with my robot Emma through the CVZone library, and it will be helping in conveying the servo angles so that our robot's limbs can move. So let's discuss what libraries are required and how we can do this. All right, so a library that you will be needing is the CVZone and the serial communication library. Just as we were declaring our serial objects within our Arduino sketch, we will also be importing CVZone's serial module over here. Sorry, we will also be importing the serial class from our serial module over here, which belongs to the CVZone package. If you haven't installed CVZone, you can just head over to your settings, file settings, Python interpreter, and install CVZone. Another library that you will be needing for serial communication is the PySerial library. So just make sure you have that installed as well. So hit install package and install the PySerial library as well. All right, so we have installed the PySerial library. Let me type in over here as well. Great. So I have imported my CVZone library along with sleep over here. So how I would be using sleep is that when I have conveyed my angle, I want my Arduino board to move my servos. So for that, I will be giving in some delay using the sleep method. Time is a built-in library, so you don't need to install it. Okay, next up, just like I was initializing my different objects and parameters within my Arduino sketch, I will also be initializing some other parameters over here necessary for serial communication. So I have my serial object class over here or function over here, which will be helping in establishing a serial communication. So if you remember, we were using the same function in our Arduino IDE. Just press your control key and head over to its documentation. So what we would be giving in is simply just the number of digits, since they are 3. Other than that, you don't need to tell it how many values you will be giving in. So I'll just be giving in the number of digits, which is 3. And for my 3 servo angles, I will be giving in 3 different values as well. So I will be declaring this object within my Arduino variable over here. All right, and next up, I will be declaring my last positions variable over here. Let me discuss why I have done this. All right, so if you remember, when we connected Emma through our PC, some of her motors, they were not kind of aligned, and the rest positions for the servos were different as we want them from. So over here you can see that the right servo is at 0 degrees, but the left servo is all the way up and we need it to be down. So this means that these are its 0 positions for all 3 servos, and we want them to be at their rest positions, which is kind of different from these positions. So for our head servo, we want it to be at an angle of 90. So we'll be giving in 90 as the rest position. And then for our left servo, we want it to be down. So for down, we will need it to code it at an angle of 180. So for that, I have my last positions or my initial positions list over here, and the left servo I wanted to be at 180, so I have given in 180 as my starting position, and my right servo was properly aligned, so I don't need to give in any different starting positions. And then for my head servo, I am giving in an angle of 90. So these are my initial positions for my servos from where I want them to start. All right, so let's discuss our main function over here, our main function that will be controlling our servos. It's by the name move servo, and let's discuss what is going on within it. All right, so it takes in some parameters, including the target position list over here, through which we will be giving in the angles as mentioned over here. And then we will also be giving in a delay, which is the delay between each step of our servo movement. Okay, next up, I have globalized my last positions so that I can call it and use it within my move servo function. And then I am declaring the number of steps that I need to take in order to achieve my target positions that I will be giving in. So for example, if all of my servos are in rest position and I want Emma to go to a specific, gesture, then I will calculate the number of steps required in going to that specific target position. All right, and then I will be running a for loop which will be sending in these angles. So the for loop would run for the number of steps that I have decided over here. And what would be happening over here is that my current position that my servos would be in would be calculated based on some steps and the previous position of my servo motor, and then stored in current positions list over here. Then these are some important steps. So in your Arduino IDE, we were getting our data using the .get method, if you remember. And here we would be sending the data using the .send method. And if you remember, we declared this as a serial object. So what I'm doing over here is I'm sending the 3 angles of my servo motors to my Arduino IDE using send data method over here. And then I am introducing some delay over here, which will allow the serial communication and movement of my servo motors. All right, and once all of this has run, it just sets my last positions as the target positions that have been acquired. All right, so let me discuss the main loop now. So what we need to do is just call our move servo function over here and give in the 3 angles of our left, right, and head servo, and then it should run. But first off, it would go into its rest position that we declared all the way up over here. So let me run this. Make sure you have connected your robot. All right, so let me right click and run. All right, so let me run my code. Right, it has connected. And right, so let me explain what just happened. All right, so you saw that my motors were quite sluggish and they did not exactly move to my rest position. Rather, they just moved to the target positions, which was 90-90, which meant that both her arms would be extended forward and her head would be in the center. And then it just returned to its initial position because the communication stopped. Now, this can be avoided by connecting it to a stable power source. Since all 3 of my motors are being powered through my PC right now, I will need to connect an external power. For that, you need to remove the external power jumper cables from your Arduino shield, and then you can connect in your batteries. So I'm using two 3.7 volts lithium batteries that I can recharge. Just make sure that your batteries are within the operating voltage of your servo motors. The operating voltage for your MG995 motors is from 5 to 7 volts. And just make sure your battery pack is like somewhere in between that. All right, I have connected external power and now I will run my code again. All right, so that was kind of fast. Okay, so you can see over here that Emma is now in the angles that I gave her. First, she went to the rest positions, which was down for both of these arms, and her head was in the center. And then all of the motors, they went to the target position, which is now 90. So we will be using this move servo function that we made, encoding in different gestures for Emma.
Hello gesture.
Alright, so now that you have your basic move servo function, you can make different gestures from it. So I'll be making the hello gesture over here. And what I've done is created a function over here. What this would do is simply just move Emma's right servo or right arm all the way up and then shake it 3 times between these 2 angles right over here. And you can notice how I'm using the move servo function that I already created previously. This way you can create more gestures for your personal robot. And for my main loop, I'm just calling the hello gesture function. So let's run this. Okay, so it goes to its rest position and then it waves 1, 2, 3. then it goes back to its rest position. So this is how we can create different gestures by using our basic move servo function over here. Okay, now let's move on to our AI speech integration.
Chapter 5 AI Speech Overview.
Our AI speech integration model is divided into three parts. The first part is speech to text, in which we'll be acquiring speech from the user and then converting it into text. Secondly, the text will be fed to our AI model, which will be Gemini API, and it will be generating a response for us in text. Finally, the text will be converted into speech using OpenAI's API. And then at last, we'll be compiling all of these three functionalities to produce a chatbot, which will be able to listen to you, think of a response, and then speak to you.
Project Setup.
Alright, so I'll be creating my PyCharm project. I'll be naming it Emma AI Robot, and then I'll be saving it within my AI Robot folder over here. And I'll be selecting my Python interpreter as 3.10.0 and then just create it. It will create a virtual environment for you within which you can install different packages. And whatever packages that you will install will be saved within your library folder over here. Next up, I'll be creating some folders. So I'll be creating a hardware folder and then a software folder and then a resources folder as well. You can download the resources from the link below. All right, next up, I will be installing the required libraries. All right, so I have a requirements folder over here already, and these are all the libraries that I will be needing for this project. So first I have my CV zone library, which will help me in establishing serial communication between my Arduino and my Python script. I'll also be using PySerial, which does the same. It helps us in communication. Then I have my speech to text library, which is VOSC. And then I'm also using Google's speech recognition library for online speech to text. You can use that as well. We'll be discussing that. Then I'm also using PyAudio and PyGame for prompting the user when to start speaking and when to stop. And then for my AI model, I'm using Gemini API, which has this dependency, Google.generative AI. And then I'm using OpenAI for my text to speech model. This is paid, and if you do not have the key, then you can use the other offline text to speech library as well, which is PyTTSX3. So I'll be installing all of this by using a command, which is pip install -r, and just put in your requirements folder and it installs all the dependencies for you. If you do not like this way, you can also head over here to your file, settings, Python interpreter within project and install it from here as well. Just make sure you have it open up in your virtual environment and are not installing locally. All right, so these are all the dependencies that it needs and it is installing them. This will take some time. All right, so it has installed all my required packages, and if you head over to your Python interpreter, you can see all the dependencies and packages have been installed. So next up, I'll be moving on to our speech to text. Next up, I'll be moving on to our speech recognition portion. So within my software folder over here, I have created a speech to text file and I'll be discussing this. So we'll be discussing two models for speech recognition. One is Google's speech recognition library, which is an online API. And then we have the VOSC API, which is an offline speech recognition model. First off, let's discuss this one. So I am importing my required libraries, which is Google Speech Recognition. And then I am also using Pygame for playing audios as prompts. So this will help me in creating, a sound which will tell me when I can start speaking and when the microphone has turned off and is not speaking anymore. For that, I need Pygame, and I'll be initializing Pygame first off. Then I have these two functions. One is my play sound function, which will be taking in the file path that I will give to my prompt audio, and then it will be loading and playing it for some certain time. Next up is my listen with Google function over here, which will be opening up my microphone for fetching the audio source, and then it will be converting it into text. So first up, I'm setting my recognizer object over here. Then I'm checking if my microphone is open. Once it is open, it starts listening and it plays the sound over here, which is listen.mp3. You can get these sounds from the description down below. Just download the resources folder. I'll be pasting in my resources. All right, so here I have my prompts. First is the listen audio, which will play when it will start listening. All right, and then I have my convert audio. All right, so I'll be using these audios and I have linked their relevant path as well and given it to my play sound over here, which will play it. And after it has played the listen audio, it will start listening using the dot listen method. And I'm passing in my microphone source and it will save my audio within the audio variable over here. And once it has stopped listening, it will play the sound that it has stopped listening and is trying to convert it now. Now, if your audio is not heard correctly, you can use this dot adjust for ambient noise method over here. I did not need to use it, so I have commented it out. So after that, I will be converting my speech into text using the dot recognize Google method over here, which will call my online Google API in order to convert my speech into text. And then it will just be returning my text and printing it as well. Now this is my main where I'm just calling my listen with Google method, and let me run my code now. Good morning, how are you today? It's not morning where I live right now, but let's see. Good morning, how are you today? Okay, so this is working. Now, one thing that I need to mention here is that if your internet connection is not stable or it's weak, then your API may not respond to you so fast and it may lag. So Google's speech recognition library is prone to latency, and depending on the length of speech that you give it, it may take more time. So I'll also be discussing the offline speech recognition model, which is VOSC. All right, so then my same software folder, I have my speech to text offline one, and I'll be discussing it now. So for this, you will need to download the VOSC models from this link over here. So I'll be heading over to the link. All right, so this is the page from where you can download the offline VOSC API models. I'll be downloading the English small model and then the large model as well, and I'll be testing both of them out. So I have already downloaded these and I have pasted them within my resources over here. So here are both of my models. So the large model is kind of big and then the other one is not as big. Wow. Anyways, all right, so just make sure you have unzipped them. So these have my models. I'll be using both of them one by one. For now, let's try out the small model. All right, so let's discuss the dependencies. I'll be using VOSC that we have already downloaded, and then I'm also using PyAudio and PyGame. PyAudio will help me in interfacing my microphone, and then PyGame will be helping me in playing my audio as before. And then VOSC will be converting our speech into text and will be saving it as a JSON file. Hence, I've also imported JSON over here. All right. Let's discuss the initializations. I'll be initializing my PyGame mixture once again for my prompt audios. Then I will be initializing my model using the VOSC.model over here. And just make sure you have provided it with the right path. Let's first try out the small English model. Then I have also initialized my recognizer using the Caldi recognizer over here, to which I am passing my model. All right, then I'm using the same play sound function, and then this is my main function, which will be listening. So just as I was doing before, I will be creating my microphone object, then I will be prompting my user when to start speaking, and then I will be recording my audio within my data variable over here. And if the user speaks, that is, if it accepts the waveform, then it stores my audio and it plays that the audio has been recorded. Then it converts the audio using the dot result over here. And then the JSON file that it saves is extracted within this text variable over here, and then it simply just returns text. Within my main loop now, I will be listening my audio with this listen with VOSC model over here, method over here. So let me just run this. So all right, so it takes some time to load your model and then it starts listening. So let's see how this works. All right, so it did not listen a few words. That is because this is a smaller model, so it may not work as accurate, but you can see how fast it is working. as compared to the speech recognition. All right, so this one is working just fine with me. Okay, it just keeps on listening. That is because I put it in my while true loop over here. So let me stop this and let me try running the other model as well, which is a bit larger than this. So let me copy its relevant path. Just the file name is enough. And I'll be pasting the file name over here. And let's try running it now. So it takes more time to load the model. That is because it is larger and is more accurate. However, this is offline, so it does not take up that much time to convert your audio and is also latency independent. For speech recognition, I have used an offline model. Alright, so I think I need to speak clearer, only then it will understand my audio. However, it does not take that much time in converting my audio into text. So we'll be moving on with the VOS model for integrating our speech within Emma. All right, that's it. Great. So next up, we will be discussing the AI model, which is Gemini API, and we'll be passing on our textual input to it, and it will be responding to us. So let's get over to that part.
AI model integration.
All right, now that we have our speech to text module done, we would move on to the AI model integration. So this is kind of the core of our project over here. We would be integrating an AI model, which would be converting our text into some response that Emma could give us. So once we have converted our speech into text, we would then send the text to the AI model and it would generate a text. Then it would return it and we would convert it back into audio for Emma. So over here within my software folder, I have added the AI model.py file. So let's look into it. So the AI model that we would be integrating is Gemini, and we would be using its API for using it within our project. Now over here in my doc string, I have mentioned a website. From here, you can generate your API key and look into the models that are available. Right, so here I am on the Gemini API's official documentation page, and over here you can check out the different models that you can use of this API. Let me explain what API means. API stands for Application Program Interface. What this allows you is to integrate an AI model into your code. And what it does is it provides kind of a gateway with which you can call different AI models within your program, and it reaches out to the AI model, which is in some basic server, and then it responds to you and sends your answer or your solution back to you. So the model that we are using is the Gemini 1.5 Flash over here. It takes all of these inputs and returns us the text as output. We're using this because this is the fastest and most stable one. So you can read over here, it's the most balanced multimodal. So we would be using this, and what we would need is an API key, which is free to generate. So you can just head over to the Get Gemini API key heading over here and click onto this link, and it will take you to the API key generation website. So it would prompt you to log in and fill in some fields, and you can do that easily. Then we will be creating an API key by simply just clicking over here on this create API key and select the generative language client over here and just simply create your API key. This will create an API key for you. All right, and you can just copy it from here and use it. So I have already created 2 API keys over here, which were free to use, but the third one I'll have to pay for it. So let me just delete it. All right, so this key over here, I can use it free of charge. You can check its documentation for how many tokens it allows, and it allows enough tokens for Emma to communicate properly. Alright, so once you have your key, just make sure you paste it over here in the API key parameter. Alright, let me explain my code over here. So first off, the library that we would be needing is Google's generative AI library, and what you can do is simply head into File, Settings, Python Interpreter, and click the plus over here and type in Google Generative AI, Google-Generative AI, and you can simply install it. All right, and after you have installed it, it should show up over here. All right, and it has installed your, all right, so you can see all the dependencies that if it has installed. So you have API core, API Python client, as your code would be acting as a client, and other dependencies as well. So just click on OK. All right, you can also use the pip command over here. So pip install Google Generative AI and it would install all the dependencies and wheels required. Right, once you have all the dependencies installed, let's head on and set up our API model. So first off, we need to set up the client key. For that, I will be first I'm importing my Google Generative AI as GenAI. It's a small keyword, so I will be using it. So genai.configure, and I can configure my code as a client or my machine as a client over here. For that, I would pass in my API key that I generated as a parameter. You can generate your own API key. I would highly recommend that. All right, next up, I have my Gemini API function over here that I have created. Wait, let me remove this line of code. All right, so what this does is it creates your model and then it just generates a response and then it prints the text. And the parameter that it is taking in is text, so it's textual input. First off, I am creating a model object using the generative model function over here, and I am passing in my model name as Gemini 1.5 flash slash dash latest over here, and it will create my model. You can search up if you want to try out other models by going to the website that I just showed you, and then you can generate your response using the generate content and pass on your textual input as the prompt. Once it returns you the response, you can simply just print it or return it through your Gemini API. I'm just printing it for now. All right, now that I have my function created, I would simply give in some text and call my function. So some text that I am giving in is 2 plus 2 is, and then I'm just passing in this text to my Gemini API over here. So let me just run it. All right, so it responded, and this is what we needed. It took some time, a few seconds to generate the response. What you can do is type in whatever you want. So let me type in something else. Right, so I changed my text over here and I'm prompting it to be my personal AI robot, and then I'm asking it what an API is, and here it gave me an explanation. So it used the typical restaurant explanation over here. It actually gave quite a long explanation. You can ask it to be brief if you want. We will be using this free API for now, but in our premium course, we will be using OpenAI's API, which will help us in prompt engineering according to our needs.
text to speech.
Right now that we have implemented our AI model, now we want to voice Emma. And for that, I will be discussing two different libraries. One is the offline and free library, which you can use, and the other one is OpenAI's API, which you can use for giving it a more humanoid voice. So first, let's discuss the offline text-to-speech library. So the Pi text-to-speech library is easy to download. You just need to go to your settings over here. So File, Settings, Python Interpreter, and just type in Pi text-to-speech, PyTTSX3, and just install whatever package or version is available. All right, so it has installed PyTTSX3 along with its dependencies. You can also use pip install for installing the library. All right, next up, I have created a function over here. And I've named it text to speech. It's taking in some input parameters over here, and then it's just giving me the voice over here using engine. So let me explain what this is. All right, so first of all, we are declaring an instance or initializing our engine, which will be converting our text into speech. Then we will be fetching whatever voices we have within our engine that we have initialized. These are the voices available which you can use. So we have one male voice and we have one female voice. You can set which gender you want or which voice you want. So 0 is for male and 1 is for female. By default, I have given in the voice index as 1, so it will have a female voice. Other than that, there are some other properties over here. So I have rate, which is the speed of my speech, and then volume, which you can adjust if you want. And I have declared these as parameters over here as well. So these are like the default values. If you want, you can change them when you call the function text to speech. All right, now that we have made an instance of our engine and set properties, now we can just give in our text. using dot say method over here of our model, and I'm giving in the text that I am taking in as an input parameter within my text to speech. And what this would do is it would convert my textual input into some voice output, and then you can run it by using the dot run and wait. So this will run whatever text you give it, and that's all about this function. Now moving on to main, what I have over here is my text, and then I'm just giving in my text to my text to speech model over here. I'm not basically returning anything here because I don't want my voice to be, I won't be passing in my voice further on, so I don't need to return anything within my text to speech function over here. All right, let me run this.
Hello, my name is Emma, your personal AI robot.
All right, so you can hear the female voice, and you can adjust its rate if you want. The voice is kind of robotic, so I'll also be trying out OpenAI's text to speech model. First off, let me just play with some values over here and change it to male. Okay, wait, I should have changed it over here, but I am just doing it over here.
Hello, my name is Emma, your personal AI robot.
Yeah, all right, so this was the free model which you can use. You can adjust the rate if you want. You just need to pass in the parameter rate, and then you can adjust the speed. This is the speed, so you can set it as whatever you want. And you can also adjust the voice. So voice index 0 is for male and 1 is for female. We will be using this function when we integrate all of the previous functionalities within one code and give voice to Emma. All right, here I have the other text-to-speech model, which will use OpenAI's API for producing sound. So a library that I had to download was OpenAI. So you can just go ahead and type in pip install OpenAI, or you can go to settings and download it as a separate package. Another package I'm using is Pygame. So we have already downloaded Pygame when we were using the speech to text model for recording audio. So we'll be using Pygame once again to play the sound that will be produced from our API. All right, so first off, I have my API key. I need to set my code as client so that it can communicate with OpenAI models. For that, you can get this key. It is paid, so you'll have to pay and get the key. But don't worry, if you don't have the key, you can use the free PyTTSX3 model as well that I have just shown you. So over here, I have my play audio function, which is the same as we discussed before. Then I have my OpenAI text-to-speech model, which is calling my AI model and then generating sound for me or generating audio for me. And then I'm returning the audio over here, which I will be playing using my play audio. All right, so down here, I have my main call or main function. So I have some text, just like I had previously. So hi, I'm OpenAI's text-to-speech model. Then I am calling my OpenAI text-to-speech function over here, and I'm passing in my text as input. And then I'm just saving the response that I get within my response variable over here and passing it on to play audio, which will play my audio. Let me discuss the OpenAI text-to-speech function over here. What this does is it takes in the text that you give over here within the input parameter, and then it generates audio for you. So you can choose the model. So I'm using TTS1 over here, and you can also choose voices. So we have different voices available if you visit the page. Hold up, let me visit the API page. All right, here I am on the OpenAI platform API page. So over here we are within the text-to-speech documentation, and you can see all these different voices.
The sun rises in the east and sets in the west.
So here are some voices that you can use. So you have Alloy, Echo, Fable, Nova, and Shimmer. So I'll be using Nova in the premium version of our course, and I'll be using Shimmer for now. You can change your variable over here and select a different voice if you want. So here is where I am calling my AI model, and then I am generating my audio within my audio content over here and simply returning it. So let me run this. Make sure you are connected to the internet.
Hi, I'm OpenAI's text-to-speech model.
Great. Let me try changing the voice, and let me try some other voice. So Alloy.
Hi, I'm OpenAI's text-to-speech model.
Great. So this was our paid text-to-speech model that we will be integrating for Emma. Now let's head on to our integration.
AI speech integration.
Alright, next up we will be integrating the three different codes that we have done so far. So what we would be doing is taking our audio from our speech to text model and then passing on the textual input to our AI model, which will call our API and generate a textual response. Then we will be passing on this response to our text to speech library or function that we created. This will help us in integrating speech recognition, AI model, and then audio output within Emma, right? So here is my main script in which I am integrating my AI speech model. Alright, so first off, I am importing all my libraries that I was importing separately for the three separate functionalities. Next up, I have my initializations. So I'm initializing my Pygame for playing sounds, and then my Vosk model that I downloaded already and is located in my resources folder. Then I am configuring my keys over here, my API keys. This is a free key, you can generate it yourself. And here I have my OpenAI key, which you can purchase easily. But you can also try out the free PyTTSX3 model as well, which I have previously discussed and integrated within this code. Alright, next up I have some utility functions for playing my sounds. Alright, so the first function that we created was the speech to text function, and I was using Vosk in it. I have just pasted the same function over here. Then I have pasted my second function, which was my AI model generation function, Gemini API, and it's the same one. I've just created a docstring over here. And then finally, my text to speech model in which I was using OpenAI. Also, I discussed the different voices that we can use for our robot Emma, and then some utility functions for playing the audio. Alright, so here I have my main loop in which I have listed down all the steps. We made all these functions separately and have discussed them in detail previously. Now I'll just be running my function. First, let me discuss. First off, we will call our listen with Vosk function, which will be hearing from us and converting our speech into text. Next up, we will be calling Gemini API, which we will be passing our textual input, and it will be generating a response by calling the Gemini API. Then we will be calling the OpenAI text-to-speech function in which we will be passing in our AI's textual response. This will generate some audio which we will be playing using the play audio function over here. So let me run this function. So it will take up some time to set up the offline Vosk model. We're using Vosk once again because it's faster as compared to Google's speech recognition library. We want to reduce latency, hence we're using this. Hello there, how are you today?
I am doing well. Thank you for asking. How are you today?
This shows that our script is working just fine. We have learned AI speech integration, and next up we will be combining both the servo movements and this AI speech integration code for bringing Emma to life.
Chapter 6. Hardware and Software Integration Integrated.
Alright, so here I have my main code and I have merged both the previous codes. So I had my AI speech integration and then I had the Hello Emma code, and I have merged both of these into this file. So I'm importing all required libraries, and then I'm initializing separately for my servo movements and my speech integration, where I was calling the APIs, initializing the keys, and then setting some initial parameters. Moving down, I have all of my functions. So my AI speech integration functions, and then my servo movement functions as well. All right, so this is where we will be calling and using all of these different functions that we previously coded. So we will be running this in an infinite loop so that our robots keep on responding to us. So first off, I'm moving Emma to her initial position. So I'm giving in my basic parameters for making both of its hands down and then its head to the front. So I have my move servo function over here. All right, next up, I will initiate my speech integration. So I will listen using Vosk, and I will be saving that within my text variable over here. And then I can call my AI model and make Emma respond. Now I've used an if else over here, and what I've done is that if the user says hello Emma or hello Emma, both of these words within their sentence, then my hello gesture would be triggered. And then it would just generate me an audio of hello, how can I assist you today? And then just play that. So this would happen if I just say hello or I just say Emma or both of these words. Other than that, if I don't say this, it will just run the basic AI speech that we integrated previously. So let me run this. All right, so it has connected to my Arduino board and now it is setting up the offline speech to text model, VOSC. This will just run once. Hello, Emma.
Hello, how can I assist you today?
Can you tell me what 2 plus 2 is?
2 plus 2 is 4.
All right, great. Now we have integrated both AI speech as well as servo movement with Emma and created our own personal AI robot.
Hello, Emma.
Hello, how can I assist you today?
Emma, what color is the sky?
The sky is typically blue during the day.
Thanks for watching. If you enjoyed the basic course, upgrade to the advanced or pro courses for more. Link in the description.